Howdy, stargazers, and welcome to this episode of Star Trails. Drew here, and I'll be your guide to the night sky for the week starting June the 1st through the 7th. This week, the rising summer triangle lets us know that warmer nights are ahead. We take a moment to explore a peculiar solar alignment in New York City known as Manhattanhenge, and later we explore the parking lots of space known as the Lagrange Points. Whether you're tuning in from the backyard, the balcony, or just your imagination, I'm glad you're here. So find a cozy spot, let your eyes adjust, and let's see what the sky holds for us this week. The moon is currently waxing. Tonight it's in a crescent phase with about 6% illumination. It will reach first quarter on June 3rd, with the full moon arriving around the middle of next week. Venus is shining brilliantly at magnitude -4, and it's just reached its greatest western elongation, making it a prominent morning star in the eastern sky before sunrise. Saturn is still visible in the early morning sky, rising in the east during the pre-dawn hours. While not as bright as Venus, it's distinguishable by its steady yellowish glow. Look westward after sunset tonight to spot a conjunction of the Moon and Mars. The waxing crescent moon will appear close to Mars, offering a picturesque pairing for evening observers. Mercury is currently too close to the Sun to be easily observed, but it will become more visible in the evening sky later this month. As summer creeps closer, the night sky starts to show off its southern stars, and this week you'll have some real stunners to track down. Low in the southeast after dark, you'll spot the curve of Scorpius, one of the few constellations that actually looks like what it's named after. Its brightest star, Antares, whose name actually means rival of Mars, is a massive red supergiant nearing the end of its life, and like Mars, it glows with a deep rusty hue. Just to the west of Antares is M4, a dense globular cluster that looks like a fuzzy star in binoculars. Right next door to Scorpius is Sagittarius, home to the famous teapot asterism. If you can trace the teapot shape, imagine steam rising from its spout. That glowing steam is actually the densest part of the Milky Way, and it's pointing straight toward the Galactic Core. Now, you can't see the center of the galaxy directly. It's hidden behind gas and dust. But you can look in the exact direction of it, which is kind of amazing. And right there, about 26,000 light years away, lies Sagittarius A, a supermassive black hole anchoring the Milky Way's spiral arms. The area around it is absolutely loaded with deep sky gems. There's M8, the Lagoon Nebula, a bright stellar nursery. M20, the Trifid Nebula, is a beautiful mix of newly born stars and dark dust. Also, check out M22, one of the best globular clusters in the sky, and also easy to spot with binoculars. Even to the naked eye under dark skies, this part of the Milky Way looks puffier, brighter, and deeper. It's like the galaxy is exhaling. And of course, the summer triangle is rising. High in the east, later in the evening, you'll see three bright stars forming a giant triangle: Vega, Altair, and Deneb. The triangle is up for most of the night and offers a gateway to other fun targets like the Ring Nebula M57 in Lyra and the North America Nebula near Deneb. Have you ever seen the sun set perfectly between city buildings, like it was aiming right down the street? If you were in New York City last week, you might have caught Manhattanhenge. That's when the sun lines up just right with Manhattan's grid, beaming down the east-west streets like a spotlight. But if you missed it, and if you happen to be in New York City in a few weeks, you'll get another shot to see it. The next Manhattanhenge is happening around July the 12th and 13th. And if you're nowhere near Manhattan, stick around because your city might have its own version of this urban sky alignment. So, what exactly is Manhattanhenge? It's a twice a year event when the setting sun aligns with Manhattan's slightly tilted street grid. The result is, for a few minutes, the sun drops directly between the buildings, lighting up the avenues in a perfect glowing frame. New York's street grid is rotated about 29 degrees off true east and west, so this solar alignment happens only when the sun's path intersects that angle, once in late May and again in mid-July. Some top spots to view it include 42nd Street, 34th Street, and 14th Street. The phenomenon was dubbed Manhattanhenge by science educator Neil deGrasse Tyson, and that, of course, is a reference to Stonehenge, the prehistoric stone circle in England that forms a cosmic calendar. And it aligns with the summer solstice sunrise and winter solstice sunset. Stonehenge has modern pagans who gather to experience the solar phenomenon, while New York City has, well, taxis. New York isn't the only place that gets this light show. Cities like Chicago, Toronto, Montreal, Philadelphia, and Salt Lake City all experience similar events, sometimes at sunset, sometimes at sunrise, depending on their grid orientation. For example, Chicago has Chicagohenge near the spring and fall equinoxes because its street grid runs true east to west. So, how can you tell if your city has a henge of its own? This is where a little digital astronomy comes in handy. There's a great tool called the photographer's ephemeris, and it lets you map the sun's path for any date and place on Earth. You can overlay that info onto your city's street grid and figure out when the sun will align with your favorite thoroughfare. It's super useful if you're chasing that perfect golden hour photo or just want to know when your city might surprise you with a solar corridor. So maybe there's a henge waiting just a few blocks from you. Let's shift gears a little from stargazing with your eyes to something that's mostly invisible but still incredibly important. Tonight, I want to take you behind the scenes of the solar system into the hidden architecture that holds things steady in space. We're talking about the Lagrange Points, those weird gravitational sweet spots that make spaceflight smarter, smoother, and in some cases, just a little bit spooky. If you've never heard of them before, Lagrange points, sometimes just called L points, are specific spots in space where the gravity of two large objects, like the Earth and the Sun, balances out just right. So right, in fact, that a third, much smaller object, like a satellite, can just sort of hang out there, using no thrusters or any fuel. It just drifts along in harmony with the big cosmic players. So picture this, you've got the Earth orbiting the Sun, and both of them are tugging on a satellite with their combined gravity. Normally, that would yank the satellite around unpredictably, but at a Lagrange point, the gravitational pulls and the orbital motion all sync up perfectly, like a cosmic dance step where the satellite always lands right on the beat. There are 5 of these Lagrange points in any two-body system. Let's stick with the big show for now, the Earth-Sun system. L1 is for sun watchers. The first Lagrange point, L1, sits directly between Earth and the Sun. It's about 1,000,000 miles from Earth, closer to the Sun than we are, but locked in Earth's orbital path. This is where we park solar observatories like SOHO and the Discover spacecraft because L1 gives them an uninterrupted view of the Sun, which is perfect for studying solar flares, sunspots, and space weather that can affect satellites and even power grids down here on Earth. It's the front row seat for solar drama, and it's always in the light. Now, L2 is a nice place for deep space stargazers. L2 is located about 1 million miles away from Earth, but on the far side away from the Sun. This spot is special because it allows telescopes to stay in Earth's shadow, with the Sun, Earth, and Moon all behind them. That makes it incredibly cold and dark, just what you want for observing faint galaxies and distant stars. This is where the James Webb Space Telescope lives. Its mirrors and instruments are designed to pick up the faintest heat signatures in the universe, so it needs that cold, quiet neighborhood. Think of L2 as the astronomer's porch, but with the light turned off. L3 is sometimes called the phantom point. L3 sits on the far side of the Sun, directly opposite Earth. It's always hidden from our view. You can't see it from here, and that's what's given rise to all kinds of fun science fiction ideas like secret planets, alien outposts, or even doppelganger Earths hiding in the blind spot. But in real life, L3 isn't all that stable. If you tried to park a satellite there, it would eventually drift away. Think of L4 and L5 as the cosmic rest stops. These points form the tips of an equilateral triangle with the Earth and the Sun. That means they lead and trail Earth in its orbit about 60 degrees ahead of and behind. L4 and L5 are really stable. Objects placed there tend to stay put even if they get nudged a little. They often collect space debris, dust clouds, and even asteroids. Jupiter, for example, has thousands of asteroids camped out at its L4 and L5 points. Earth has a few too, though they're much smaller and harder to spot. Some scientists even speculate that alien probes, if they existed, would choose L4 or L5 as a parking spot. They're hidden, stable, and offer a great long-term view of Earth. So what makes these places so valuable? For one, they reduce the energy needed to keep spacecraft in a fixed position. That means less fuel, longer missions, and more stable instruments. And for future space infrastructure, things like observatories, solar power stations, or even planetary defense systems, Lagrange Points offer premium real estate. They also give us strategic vantage points, whether we're monitoring solar storms, peering into deep space, or preparing for interplanetary travel. These points let us place our tools exactly where they'll be most effective. So the next time you hear about a new space telescope or satellite mission, listen closely, and there's a good chance it's heading for one of these gravitational sweet spots, where the math of motion and the poetry of space come together just right. If the stars spoke to you this week, or if a question's been on your mind, I'd love to hear it. Visit our website, startrails.show, where you can contact me and explore past episodes. Be sure to follow us on Mastodon, Blue Sky, and YouTube. Links are in the show notes. Until we meet again beneath the stars, clear skies, everyone.